This is Brianna, Shin, and Jenny's Engineering 305 Data Analysis Methods and Modeling Final Project. We will be discussing our echocardiogram data analysis results. For this project, we used echocardiogram data. We hypothesized that age has an effect on survival after having a heart attack. To analyze the data and test the hypothesis, we used JUMP to perform fit Y by X, bivariate analyses to determine important factors and relationships, chi-squared tests for independence, and a one-way ANOVA. We will also discuss a synthesis performed between heart attack and survival versus Parkinson's and survival using logistics regression for prediction. The main research question that drove our analyses and tests is, does age determine survival within 1 year of having a heart attack? Other questions that influenced our analysis include which factors have the greatest influence on survival, do age and LVDD levels have a strong correlation, and does wall motion index have a strong correlation with age? The main question for our synthesis is, can we test 15 random patients based on our analysis to determine if they will be alive after a heart attack versus diagnosis with Parkinson's? Our original null hypothesis is that there is no difference between age and survival within 1 year of having a heart attack. The alternative hypothesis is that age does affect survival within 1 year of having a heart attack. The datasets that we use are the echocardiogram data for heart attack data and Parkinson's with Parkinson's disease data. The main underlying distribution is exponential because the main question we are trying to answer concerns time to failure of heart attack patients. For the synthesis, we are comparing time to failure of heart attack patients with patients diagnosed with Parkinson's. The chi-squared underlying distribution is used for factor analysis. For some examples, we have alive versus age, fluid versus age, ANOVA for LVDD and age, and distribution of age on heart attack patients. To analyze our data, we used hypothesis testing and conducted fit Y by X, bivariate analyses, chi-squared tests for independence, and one-way ANOVA. For our synthesis, we used logistics regression.
This is a demonstration of the chi-squared test. On JUMP, we conducted a fit Y by X and used age as our X factor, and whether they were alive after 1 year as our Y response variable. The response variable is binary, 1 for alive and 0 for dead. Using the contingency table, we were able to see the likelihood of being a specific age and survival likelihood after 1 year. The contingency table shows the actual numeric counts of each category. This is a chi-squared test on the count of patients who survived or died after a year of having their heart attack. There seems to be a higher count of patients who died around the ages 54 to 59, and then again from 63 to 70. We believe that this might be due to the fact that when the data was collected, the team of collecting the data did not take into account to collect data from a set number of patients from each age. After doing a distribution of the age in the patients, it is evident that the majority of the patients are ages 60 to 63, adding more counts to those categories.
In order to synthesize our research, we performed a comparative study on the dependency age has on survival for two different conditions, one being post-heart attack, which has previously been discussed, and the other being post-Parkinson's disease diagnosis. Each of these conditions have milestones that are believed to be significant accomplishments following a heart attack or diagnosis. For Parkinson's disease, the milestone is 10 years following a diagnosis, and for a heart attack patient, this is 1 year. As you can see, the distribution of patients that have died 10 years after a Parkinson's diagnosis is generally less than patients who have died 1 year following a heart attack. To analyze the Parkinson's data further, we performed a chi-squared test to determine the effect of the age of diagnosis on survival 10 years after diagnosis. Being that the R-squared value is approximately 0.087, age causes a very minimal effect on the likelihood of death 10 years after a patient is diagnosed with Parkinson's disease. However, it is mildly dependent. Analyzing both of these data sets using the R-squared value, we may determine that survival after heart attack is more dependent on age than survival post-Parkinson's disease diagnosis. With an R-squared value of approximately 0.26, the age of a patient is a variable that affects the likelihood of survival 1 year post-heart attack. When a heart attack patient is of the approximate age of 60 to 63, a patient has a greater likelihood of still being alive after 1 year.
Our original hypothesis states that there's no difference or significance in the age and the survivability of a patient as our null hypothesis. However, after running some tests, we can say that we should reject the null hypothesis because there is significance between age and survivability within a year.